All right, Math 1 graphing with X and Y intercepts and standard form. So starting off, we're doing number 1 with just the intercepts listed. So let's look at the y-intercept first, because I think we already know what that is. Y-intercept to be a -1 means that we just put a dot on the -1 on the y-axis. See, there's the y-axis. Here's the x-axis. The x-intercept of 5, I'm going to put a dot on the 5. You have to have 2 points to make a line. We have 2 points, and we can draw our line. Right? And remember that lines have arrows on the end of them. There we are. That's our line. Let's look at the next one. We'll do the x-intercept first this time. So it says we have an x-intercept of -5, so we're going to put a dot on the -5 on the x-axis. The y-intercept is at 3, so a dot on the 3, and we draw our line through it. There we are. Number 3, x-intercept of 5, we put a dot on the x5. The y-intercept of -4, we put a dot on the -4. Remember, we're looking at the axis labels there, right? Or we can just remember that the y is the vertical axis and the x is the horizontal axis. We've got 2 points, and we can draw our line. Number 4, x-intercept of -5, so I look at my x-axis, the horizontal axis, and I put a dot on the -5. For the y-intercept, a dot at -1, and we draw our line through it. There we are. And remember again, lines have arrows. All right, that's the front side of this. Hopefully that was pretty easy for us. And let's look at the back side. Now, a really quick and easy way to graph standard, or not just standard, general form, I guess standard form, some people call it standard form, whenever it's listed like this, is to try and list our intercepts first. So we have our x-intercept and our y-intercept. Now for our x-intercept, it will always be something along the lines of x comma 0, where our y is 0. And for our y-intercept, it'll be just the opposite, 0 comma y. Now what we're going to do is we're going to plug in to the formula, or to the equation, to get our x-intercept and our y-intercept. So I'll start off with the x-intercept over here. I'm going to plug in a 0 in for y. So I'm going to have, well, 3x minus 0 equals 1. 3x equals 1. X is 1 over 3. So that's our x-intercept, and we can put a dot on x is 1/3, and we just have to guesstimate where that would be. For the y-intercept, we're going to do very similar. We plug in a 0 for x. We're going to have 3 times 0 minus y equals 1. 0 minus y is 1. Negative y is 1. And we end up getting -1. And there we are. We can draw our line through that. So that's how you can very quickly draw or graph standard form or general form, whichever one you want to call it, using intercepts. Let's go straight down to number 7 next. So we're going to have our x-intercept and our y-intercept. We remember that for an x-intercept, that means we have something like x comma 0, and y-intercept means something like y comma, or 0 comma y. So I'll plug in 0 for y first. So I'm going to have x plus 2 times 0 is 8, so x is 8. Now that kind of goes off our graph, but I'm still going to try to draw it on there. We'll say that that's our point. And for the y, we're going to plug in 0 for x, so 0 plus 2y is 8. Y is 4, right? We divided by 2 there. So if we look at this a little bit, we can kind of see that it will get we can do this really quickly in our head, right? If you look at number 7 and you try to plug in a 0 for y, well, you kind of go like, well, this guy just goes away, and x is 8. Similarly, if you were to do it for the x, you'd say, well, this guy goes away, and you'd have 2y is 8, divide by 2, and you have 4. So we can do those kind of quickly in our head, but we can always write them down if you want to, like I did. Draw a line. That's not that great. There's a better line. And there we are. All right, let's look at number 6. Now, we have 5x minus 4y equals 0. Now, whenever you end up getting a standard form or a general form equation that is equal to 0 like this, if you try to plug in 0 for x or y, you'd end up getting that the x and y intercept is 0. So all that tells us is that we have a point right there on both of them. That's not very useful. So we're going to need to rearrange this. We're going to need to find the slope. The way that I would do that is I would just rearrange it, and I'd say, well, I'm just going to copy down 5x minus 4y is 0. Well, that's the same thing as 5x equals 4y. And if I'm trying to get my y by itself, I could say, well, 5 over 4x is y. So that tells me that my slope is 5 over 4. So I can go up 5 and over 4, or I can go down 5 and left 4. And I can graph just like that. There's our line. So whenever you go to graph these, I think the best way to do them, the fastest way to do them, is to find our intercepts, like what I did in number 5. But if you can't do that, if you have a 0, or if you're just really uncomfortable with that, just graph it like normal. Graph it like you would whenever it was in slope-intercept form. All right, let's look at number 8. Number 8, if we got our x and y intercept, well, our x-intercept, we plug in a 0 for y, so this guy just kind of goes away, and you get x equals negative 20. Well, that's going to go way off the graph. Let's look at what our y-intercept would be, though. If we look for our y-intercept, we're going to kind of cross out our x there because it goes to 0. And we've got negative 5y is negative 20, so y is 4. So we got our y-intercept, but we don't have our x-intercept. We're going to need to find our slope so that we can find another point. Just to review, I'm going to use negative a over b. Remember that there's a, there's b. This is going to be negative 1 over negative 5, which is 1 over 5. Right? Remember that there's a little understood 1 right there. That's our formula to find slope. So 1 over 5 means go up 1 and over 5. Does it mean up 1 over 5? Yes, up 1 and over 5, I'm sorry. And then down 1 and left 5. I was looking at this negative 20 and I was concerned that the graph wouldn't work. I was trying to plot it in my head. So there we are. So up 1 over 5, down 1, left 5, and we got our line right there. So these are just more ways that we can graph lines. I think the intercepts way, especially in number like 7, well, it kind of went off the graph, but number 7 was a good example though, where you can just kind of cover up one of them and you can find the intercepts really quickly. So that's kind of useful. All right, that's all.